In this video, I'm going to show you how to fix, repair, or replace damaged RGB light strips as shown on screen, using a ProTech compact soldering iron. And welcome back to another video. In today's video, I'm going to be showing you how to replace or repair some broken strip lights. So as you can see here, we've got a tear here, and on one of those boards that are just off camera, there's a damaged light, which I'll also be replacing, which is the same scenario as these strips here. So here I've got a portable, non-sponsored soldering iron, and it's from ProTech. So what I'm going to do is I'm going to turn the power off to this light strip, and then I'm going to replace the section between the cutout, the snip points here and here, and replace it with some strip lights which are the exact same, and just solder it in to fix that connection that has failed, as it's failed right by where the light ends. So what I'm going to do is I'm going to set you up closer, and then I'll give you a better shot. But before I do that, I'd like to welcome Loki. Now, Loki here is a trainee in the process, and he is helping me today, and hopefully he gets to learn some new skills. So, right, should we get started? Cool. Okay, so the first thing we're going to want to do is we're going to want to identify where we can snip. So right here is a connection where we can snip and we can solder onto. So what I'm going to do is, they say to cut halfway in between, but what I'm going to do is I'm just going to cut just about there. So we've got this open connection here now, and then I have to identify where the next one of these on this side is, which is right there, and I'm going to do the same. So peel this off and cut there. Now honestly, you can cut on the line, but I like to keep lots of room in case the new piece I put in is a little short. So this is our new strip, and here's our connector points, and so I'm going to cut this wee bit off the end here, and we're going to locate our next piece that we can snip out, which is here. Let's just quickly do that. Now for this one, because we've got the excess on that side, we can cut this one in the center in case we need to use this light strip again. So we'll put that there, and here's our light strip, and as you can see, it's one full set. But thankfully with this set, both the sets here and here are the same length. So what I'm going to do is we'll crank this up so it heats very quickly, and then we'll get to soldering. Okay, so here's our strip. Now what I have to do is I have to rest this here and try and connect it up. So currently I've got this strip upside down, as you can see. So if this strip was installed upside down, this strip that we're soldering in wouldn't work, and the power would go straight through and power the other lights in theory. So we're going to flip that around till it's the right orientation. And we have to make sure that the pads line up. So positive and positive, negative green, negative red, and negative blue line up. So what I'll do is I'll peel the back of this off slightly. And then we'll peel this piece off, just like that. And now with this guy here will hold the connection, but we need like a little bit of paper so the claws don't crunch down into the strip and ruin it again. So here we go, take that. And I will speed this up for you guys until the important parts. We'll do the same here as well. Cool. So now I have to solder these points together. As you can see, blue and blue, red and red, green and green, and plus and plus. So some people like to use flux. I'm using just ordinary solder wire here, solder wire, and this has flux already in it, but for the people that like to use the liquid flux, I recommend you just put a dab on the end of your wire, simply because if you put too much and you don't wipe it all away, it starts to corrode. Rightio, so we'll see if I can stop shaking. So I'll just take a close look to see if that has actually lined up. It does look like it has made a connection there. But just to be sure, I'll go over it again. Now you don't want to go over it too many times, simply because you'll start to wreck the connection contacts between the two. Okay, that's made a good contact. Now if you end up shorting this out, because this is a 5-volt strip, the only damage you'll do is potentially damage to the controller, or the controller will just turn off. So now I'm going to do this again with all the other ones. Stop shaking again.
How does it melt the wire and doesn't melt the metal thing there?
So solder wire has a very low melting point. So the iron here heats up to a high enough temperature that it melts this, but this is usually made out of a higher melting point material, so it won't get hot enough to melt this, but it's hot enough to melt the solder wire.
Oh, okay.
So we'll zoom out and see if that has done its magic, and we haven't made a connection yet. So we'll just... There we go. Now, your solder joints should look very nice and shiny. If they don't, that means that your soldering iron might be on quite a low heat. So my last soldering iron used to just plug into the wall, and you could not control how hot it got. So most of my solder joints came out like crap.
So does it matter if you cover the whole thing?
Yes, it does. So if I covered the entire thing here in solder, it would short the connections out. So if I were to connect the plus to G and the controller turned on ground, Some of the strip may light up, but anything past this point would stop working completely and you'd have a short. And it looks like I was pretty close to making a short between there, but we're all good.
So, does it matter that you're covering? Oh, sorry, that you're covering the all the orange bit and the little bit at the end?
So all you really have to do is you have to connect. You see where it is broken there? Mm-hmm. That's where we've overlapped it. So it's overlapping the copper, but the copper isn't actually touching the other terminal. So the solder just connects those two. So even if you did the whole thing and it still made a connection, it would work. But if you didn't have that connecting, those two bits actually touching with the solder, then it would not work.
Okay.
Short answer. No, you don't have to solder the entire pad, as long as a connection has been made.
So how does the school just let you do this correctly with their lights?
So, because I know enough about the lighting myself and the fact that this is a low voltage circuit, so anything under 12, I'm mostly happy working on under 5 or 12 volts, but some people can go up to like 18 volts on these circuits. Because this is a 5-volt circuit, if I did something wrong, the worst case scenario would be that we fry the controller. Because the power supply that provides the power through USB would just cut out because there's too much power being drawn from it, and a safety circuit should engage, and if it doesn't, then it's just power pretty much finding a way to earth again. So, not earth, negative. So, in household wiring, you've got 3 wires. You've got positive, negative, and ground. And there's so many different names for them, but I'm not going to get into that. So, let's say 5 is our positive, our inlet, right? And let's say, you see how it says green, red, and blue? We've got a dimmer on those, but just think of it like we've got 3 switches. The switch turns on, allows green to go to negative. So the power has to go through 5, through all the lights, and then back through the green terminal, the G, to ground. And that's how a circuit works. But you can turn multiple switches on and get white, pink, or yellow. But with dimmers, you can very finely adjust how much output each light does, so you can get a much more wider range of colours. Because it is a low circuit, it will be safe to work on. Okay, so this side is done now. Now we're going to move on to the other side, so we can disconnect this. And we can stick that back, just like so.
Yeah, you're just going to have to remove this.
Yeah, so we'll remove the sticky on this bit till the point we don't want to remove it. So now, really, you shouldn't be trying to stick the strip light to wood like I'm doing, and this wood is chipboard. The reason this is because chipboard has more gaps in the ends of it, so there's less surface area for the strip to hook onto. The best surfaces are clean and not dusty ones, and that have a lot of surface area that can be covered. So here with this one, I do want to peel it up a wee bit, but not too much. We'll bring our handy dandy little helper over here again. Put that in. Or should I say, put this in like that. So as you can see here, they pretty much perfectly will line up. So I'm going to peel. So this side here, we've got lots of sticky, but what I'll do is I'll overlap it like this. So I'll shift you guys again. So you take the peel off this side. Now, if you want your light strips to stay flat and nice, it is a good idea to try and match them up so that they are soldered flat, kind of like that, like we did before. The reason why we do this is so your strip doesn't randomly come along and then it's soldered on an angle which makes the strip go some other direction unless you wanted it to go that direction. Rightio, and we'll do the same here. We can speed this one up since we showed you the process before. Now, what I recommend is you can get some special scrubber for your iron. So when it's hot, you can just shove it into the copper wire and it cleans the solder off the end of your soldering iron so it doesn't smoke like mine is. And that also preserves the lifespan of the iron to an extent. Now, sometimes these fumes can be quite toxic in general. Oh, so you want to have a go with this one? Okay. So I'll put this in here for you. And shift. It can be toxic if you breathe it in a lot, but for a short period of time. Oh, did you burn yourself? You will have to heat up that more. Yep. Good job. Looking pretty good though. I'll just double check that that has made a connection and then we'll power it up and see if it's all working. Yeah, beautiful. Well done.
Thank you.
First time's luck. I used to get that wrong all the time. Probably because I was using a bulky soldering iron. Big one. Sorry guys, we just had a good question from Loki. So he said, if you stuff it up, how do you fix it again? So there is a special type of wire you can get, and it's a copper wire, and you can stick it on the end, and it's like a wick. So you heat up the solder, put it there, and it sucks up all the solder, and then you've got a clean platform to start again. Otherwise, what I do, because I haven't got the a option like that here, I will find a random piece of stray wire, because I have a lot of that at home, and I will heat that up, and that will somewhat act like a wick, although it's not as good as the original wick design. Right, would you like to pop over and turn the big switch on?
You got it.
And would you look at that? We have power, baby. The power of soldering. And that's our other one there. So the best idea would be to test to make sure all of these work. But as I can see, they are all hooked up, so I can only assume. But if I have to, I can come back and fix that up. So now I'll do a time lapse of fixing that board over there. As you can see, in that corner, from that corner onwards, there's no light. So I'll do a time lapse of me fixing that. Awesome. Okay, so now this is our LED at fault, and as you can see, the LED itself that I'm holding doesn't light up because it's that damaged. So what I'm actually going to do is right there, we've got another cut in, cut out. I'll cut that out, and then our next one is here where we can cut it out. So next I'll unpeel it, and then we'll get to soldering. So time lapse. Well, there you go. Working just as intended. As you can see, green when there's green, blue when there's blue, red when there's red. Same over here. Now the funky thing with this is that if you really didn't care about the order here, you could adjust what colour goes on what. If it will focus, please. It won't focus, guys, hang with me. So, if you really didn't care about the focus, if you really didn't care about the order that these were soldered in as, you could switch the orientation. So let's say you could connect blue to red, red to green, and let's go green to blue. So then when this strip is green, this would be blue, and this side is blue. This side could be red or green, and if you had green, this could be red. So you could adjust exactly what colours turn on at what time. As you can see, we want the entire strip to all change colour in unison with the proper colours, so we've just soldered it up as is. But if you really want to make a really cool sign with these lighting it up, well, I mean, you could do that, and you could change the colours how you like. Cool. Thank you all so much for watching, and I hope you really enjoyed this video.